Hi everyone, a very good morning to all of you. Now we are going to study about question number 63, that is combination of lens. And also we study here what is silvering of a lens. So majorly about combination of lenses, thin lenses kept in contact. So when you kept thin lenses in contact, the combination behaves like one single convex lens or concave lens. So what is the effective focal length of that combination? We need to understand here. And the very first thing what we have to understand here is what is power of a lens. So power nothing but the ability to deviate a light ray when it passes through it. Like when you consider a ray, when a ray is coming parallel to its principal axis at unit distance, then it will pass through focus. That means it will get deviated through some angle. That delta is called deviation. Now, that deviation, if it is considered delta, then tan delta is approximately equal to delta. That is equal to opposite is unit length, I said. The ray should come at a unit distance, unit perpendicular distance from the optical center. 1 by f. This is called power of the lens. And power we always measure in terms of per meter. Also call it as diopter. So if you want to take f in terms of centimeter, then it will become 100 by f. So the formula will become. So power formula will become 100 by f in centimeter. Then you will get centimeter get cancelled, so that you will get diopter. Now the next thing is what is the effective focal length of combination of lens. So when you consider two thin lenses in contact, like having focal length f1 and f2, then the focal length is given by 1 by f equal to 1 by f1 plus 1 by f2. If there are 3, then plus 1 by f3, so on. Or there are sometimes they can give like they separated by some distance d. Then 1 by f equal to 1 by f1 plus 1 by f2 minus d by f1 f2. Nothing but effective power equal to p1 plus p2 minus d p1 p2. As they kept in contact, distance will become 0, so that 1 by f equal to 1 by f1 plus 1 by f2, or else p equal to p1 plus p2. Convex lens means positive focal length, positive power. Negative concave lens means negative focal length, so that the power is negative. You have to take positive as positive, negative as negative. Now the next thing is what is the focal length of a silvered lens. When you consider any lens, let's take suppose a convex lens is there. Then the focal length is 1 by f equal to mu minus 1 into 1 by r1 minus 1 by r2, where r1 is plus r and r2 is minus r. Now when you silver one surface, then it behaves like first refraction plus reflection, then again refraction. It is a combination of two lens and one mirror, so that the effective focal length will become 1 by FL plus 1 by FM plus 1 by FL. You have to take the magnitude. So 1 by F equal to 2 by FL plus 1 by FM. This is the effective focal length of a silvered lens. So they can give any silvered lens. Plano convex lens may be silvered one side. Either plane side may be silvered, or curved surface may be silvered, or convex lens may be silvered one side, or concave lens may be silvered one side. Then it acts like a mirror of some effective focal length. So that effective focal length you can find from here. Then accordingly you can calculate. It may act like concave or convex mirror. Now the next thing is cutting off lens. So when you consider a lens, so the focal length is mu minus 1 into 1 by r 1 minus 1 by r2. So if you substitute the value mu minus 1 into 1 by r plus 1 by r equal to 2 into mu minus 1 by r. This is the focal length, 1 by f value. Now you can cut the lens into two parts along the line perpendicular to its principal axis or along the principal axis. Suppose when you cut like this, then focal length will become f1, f2. Here radius of curvature remains same, rr, so that f1, f2 both become equal to f1. But when you cut it like this, then one of the surface became plane. That means r1 or r2 becomes infinity. So that here the effective focal length 1 by f1 or 1 by f2 will become mu minus 1 into just 1 by r. That means f1, f2 both will become double that of initial value. So when you cut along the principal axis, then the focal length remains same. But when you cut it along the perpendicular axis to the principal axis, then focal length becomes double. Now after cutting, you can keep them in contact. Like this is one lens, this is another lens, this is another lens, like that. Now again, the effective focal length will become 1 by f1 plus 1 by f2, so on. Like that, they can ask questions based on even cutting off a lens. So this is what the basic idea and the basic formula which is required to solve the questions based on combination of lenses. Or sometimes they will also keep like, see, the two convex lenses are there like this, and now the space between them is filled with some medium like this. Now it is the combination of two convex lens and one concave lens, or else between two concave lens they may fill some medium, so that it will behave like combination of two concave lens and one convex lens. Such kind of questions also they can ask. So that you have to take three lenses and you have to find each focal length. Then the effective focal length will become 1 by f1 plus 1 by f2 plus 1 by f3, so on. So this is how you have to deal with it. Let's see few examples based on whatever we have studied. Now the very first thing is, three lenses in contact have a combined focal length 20 centimeter. Three lenses are in contact. That means 1 by f1 plus 1 by f2 plus 1 by f3 equal to 1 by 20. When the third lens is removed, that means now only two are there. That means now 1 by f1 plus 1 by f2 is 1 by 100. Now the effective focal length is 1 by 100 only. So that if you substitute this in the first equation, then 1 by f1 plus 1 by f2 plus 1 by 100 by 1 by f3 equal to 1 by 20. So 1 by f3 equal to 1 by 20 minus 1 by 100. So 1 by f3 equal to this if you solve it. So 100 minus 20, that is 80 by 20 into 100, 24 are. So f3 will become how much? 25 centimeter. And it came positive means it must be what kind of lens? Converging lens. Converging nothing but concave lens. So that the way you have to understand and you have to apply the formula whatever we have studied. Now here is the another question. A thin convex lens of focal length f is cut into two halves along a vertical plane. Now they cut it into two like this along the vertical plane. The two halves are kept in contact with their curved surfaces in contact like this. Now what they have done is, they kept them in contact like this. But as we have seen already, when you cut it like this, the focal length will become 2f. Initial focal length, if it is f, then the combined focal length of the lens, so 1 by f equal to, now 1 by f1 plus 1 by f2 equal to 1 by 2f plus 1 by 2f equal to 1 by f, so that the focal length becomes f. The effective focal length will become f. So this way, as I said, they can cut and take the combination of lenses. Now the next question is a converging lens of focal length. So converging lens means concave lens. Focal length is 5 centimeter. Is placed in contact with a diverging lens means concave lens. So the focal length is minus 10 centimeter. So that when you kept them in contact, 1 by f1 plus 1 by f2 equal to 1 by 5 minus 1 by 10. So 1 by f equal to, so minus 5 by 50. No, sorry, plus 5. So that 1 by 10. So the focal length will become 10 centimeter. Now, next thing is a thin equiconvex lens has focal length and refractive index. One of its faces is now silvered. So one thin convex lens, equiconvex means nothing but R1 equal to R2 equal to R. And the focal length is 10 centimeter and the refractive index is 1.5. Now it is silvered. One of the sides. The image coincides with the object. Here the image should coincide. Now see here. Here it is a combination of. Now first thing you have to find the effective focal length. That is 2 by FL plus 1 by FM. Now 2 into 1 by FL. 1 by FL nothing but focal length of the lens. Focal length of the lens, how much it will become? 1 by F equal to mu minus 1 into 2 by R. Because it is a convex lens. Plus, now it is like mirror, concave mirror. Just like this. So that the mirror focal length means half of the radius. So 1 by R by 2. Now 1 by focal length will become 2 to 4 by R into mu minus 1. Mu is 1.5 minus 1, so 0.5 plus 2 by R. Now 1 by F equal to, how much is the value? This is 4 pi is 2 by R plus 2 by R equal to 4 by R. Now the focal length will become R by 4. So radius of curvature will become. Now how to find the radius of curvature? So thin convex lens focal length means 1 by F equal to mu minus 1 into 2 by R. Now from here R equal to 2 into mu minus 1 by R. So that 2 into 1.5 minus 1 by, focal length. Focal length of the lens is 10. So you substitute 10. So radius is now 0.5 into 2, 1. So 1 by, okay, sorry. So small mistake. See here, from here, we have to find radius of curvature, that is 2 into mu minus 1 into F. So 2 into 1.5 minus 1 into focal length 10. So it will become 10. Radius of curvature 10. So 10 by 4. So what is the effective focal length will become? 2.5. So Now it will behave like a concave mirror because it is reflecting back. So the image should coincide with the object means real image should form. So it is behaving like a concave mirror means in which case the image and object coincides is when object is placed at the center of curvature. So focal length 2.5 means what is the radius of curvature will become 5 centimeter. So what is the distance of object will become 5 centimeter. So if you place it a distance 5 centimeter, then the combination will behave like a concave mirror of focal length 2.5. That means center of curvature will be located at 5 centimeter. Then if the object is at center of curvature, then image also coincides with the object. So that's the way you need to understand how the question is given and what are all the rules to be applied in the image formation. Now, two equiconvex lenses, each of focal length having focal length 30 and f1 is 30 and f2 is 70, made of material refractive index is 1.5, are held in contact coaxially by a rubber band round their edges, a liquid of refractive index. So there is one convex lens, there is another convex lens. Now this is completely filled. That means now it will behave like one convex and one concave and one convex. Now f1, f2 they have given. Now f3 we have to find. Now 1 by f3 will become mu minus 1. So here the liquid, this refractive index is something mu dash if you consider mu dash minus 1. It is like a concave lens made of material 1.3 into 1 by minus r minus 1 by r because it is concave lens. So that 1 by f3 value will become mu dash minus 1 into minus 2 by r. Now find the position of the image of luminous point object placed on the axis of the combination lens at a distance of 90 centimeter. So first you have to take the effective focal length of the combination. See here, one small thing is actually we are taking R, but both are not of same focal length. See, when you consider the focal length of a concave lens, mu minus 1 into 2 by r, where mu is 1.5. So 1 by f equal to 1 by r. So f value is r. That means now r1 is f1 and r2 is f2. So both sides the curvature is not same. So you have to take r1 and r2 separately. Then the equation will become like this. See here minus will come out. So 1 by r1 plus 1 by r2 where 1 by f3 will become now mu dash is 1.3 minus 1 times 1 by r1 means 1 by f1 plus 1 by f2 but one minus is there. So f1 is now 30, f2 is 70. You substitute then you will get 1 by f3. Then 1 by f will become 1 by f1 plus 1 by f2 plus 1 by f3. Then you will get the resultant combination. Now like see this, if you calculate it you will get it 1.3 minus 1 is 0.3. So minus 0.3 by 1 by 30 plus 1 by 70. So that minus 0.3 into 100 by 30 into 70. So 0 point cancel, 3 tens are 10 tens cancel. So 70. So F3 value will become minus 70. Now 1 by f equal to, now 1 by f1 means 1 by 30 plus 1 by f2 is 1 by 70 is 1 by 70. So 1 by 30. So the effective focal length is 30. Now the combination is behaving like a convex lens of focal length 30. Then you can apply formula 1 by v minus 1 by u equal to 1 by f, where 1 by v minus the object is placed at a distance 90 centimeter from the combination. That means object distance will become 90 by 30. So then you will get the final image distance. Because instead of giving one lens, they have given combination of lens. Then first what you have to do is you have to find the combined focal length. So when you get the combined focal length, then you can treat it as one lens. For that lens, for the given object distance, we can use the lens maker's formula and we can find the image distance. So this is how you need to deal with the questions based on combination of lens or silvering of lens and cutting of lens. So similar questions are given as an assignment. So please try to solve all of them. And in NCERT also they have given questions based on the same concept. So try to solve all the questions. We'll continue in the next class with the next question. So thank you all.